were discussing about the motion in a plane. We have discussed about the vectors, terms related with the vectors. And also we have discussed about the position vector and the displacement vector and how to add the vectors that we have done. And also I have told you in the last class that about the vectors I will be discussing one topic like if your vectors are not collinear. If your vectors are not collinear, then how will you add the vectors? Now let us see how if the vectors are not collinear, then we have to use the laws of addition. Okay, laws of vector addition. So what is the laws of vector addition? There are two laws of vector addition. One is your triangular law of vector addition and one is your parallelogram law of vector addition. So first of all, I'll start with the triangular law of vector addition. Why do we use the triangular law of vector addition? Suppose if your vectors are not collinear. Suppose if I show in your diagram, suppose there are two vectors, like one vector is in this way, this is vector A, this is another vector B. How will you add these two vectors? For adding these two vectors, we cannot use the direct law of addition. Directly adding the tail with the head of the other vector, we cannot do that. For this, we have to use the laws of addition. For this, we'll be using the triangular law of vector addition. Triangular law of vector addition. How to use a triangular law? The rule of addition is exactly the similar only. The tail of this should be touching with the head of the second vector. So you will be doing it this way. This is vector B. Your vector A should be touching in this way. So you can see the tail of the first vector is touching with the head of the other vector. Clear? So these are the two vectors, how it is represented. Now how will you calculate the resultant, that is the total value of A and B? According to the triangular law of vector addition, it states that if two vectors are represented by the two sides of the parallelogram, the resultant will be represented by its third side. By its third side, which is taken in opposite order. Why it is written as taken in opposite order? Because you can see here both the tails are touching. But according to the rule, your tail and head should touch. Here you can see the head and head are touching. So the resultant vector, which is represented by R, it is taken in a opposite order. Yeah. So if you write the statement of the triangular law of vector addition, it states that if two vectors are represented by the two sides of the parallelogram, the resultant will be represented by the third side of the if the two vectors are represented by two sides of a triangle, resultant will be represented by the third side of the triangle. So here your answer will be R will be equals to vector A plus vector B. This is in a vector form. We need to do in a scalar form. How will you do it? You see. If you see this triangle, since this is not in a right angle triangle, you have to make this into a right angle triangle first. First, convert this into a right angle triangle. Mark the point as P, Q, R and S. Yeah, P, Q, R and S. Mark this angle as alpha. Mark this angle as theta. Okay, I have taken two angles, one is alpha and the other one is theta. I will be calculating the value of the resultant now. How will I do it? In triangle, suppose PQS, in triangle PQS, if I use a Pythagoras theorem, it will be PQ squared is equals to PS squared plus it will be QS squared. Okay, PQ square plus PS square is equals to PS square plus QS square. Now, if I calculate now, PS square, this PS square you can see it is divided into two parts. So, in place of PS, I will be writing PR plus RS whole square plus QS whole square. Mark this is equation number 1. Why? Because we don't know the value of PR, we know, but we don't know the value of RS. And we don't know the value of QS. We need to calculate that value first. So for that, I will be using this triangle. In triangle RQS, in this triangle, you use sin theta. Since this is theta, so this will be a base, this will be a hypotenuse, this will be a perpendicular. So sin theta it will be QS divided by it will be QR. Clear? So QS will be equal to QR sin theta. QS is equal to QR sin theta. Now this QR has a value of, okay, this is QR has a value of A. So this will be equal to A sin theta. This is the value of QS. Same way if I calculate the value of cos theta from the same triangle, base by hypotenuse, it will be RS by RQ. Clear? Then RS by RQ, if I do it, it will be RS will be equal to RQ cos theta. Okay, RS will be equal to RQ cos theta. Then if I put the value of RQ from here, again it will be A cos theta. Now we can put the value of A sin theta and A cos theta in the equation number 1. So if I put in equation number 1, it will be, this side we have, it was PQ square. So PQ square will be equal to PR will be, PR is from here, it will be B plus RS is this part, so RS we have calculated it is A cos theta whole square plus it will be A sin theta whole square. Clear? Then after that if I solve it, so this will be B square plus A square cos square theta plus A square sin square theta plus this will be 2A cos theta, 2AB cos theta. Then after that, if I solve it, this A square cos square theta and A square sin square theta, if I take that as a common, that will be equal to 1. So it will be B square plus A square plus 2AB cos theta. Okay, and this PQ square is nothing but your R square. So R will be equal to root over A square plus B square plus 2AB cos theta. So this is how we have to do. This is equation number 2. This is how we need to calculate the resultant. Next class will be calculating the value of the resultant angle, that is the alpha. Clear? So this much for today. Thank you.